So we're still working on 5.5, right? So I'm saying 5.5 continued here, integration methods. So I just want to do a couple of problems from last class, and I'd like to do this. I'd like to answer questions that you have. If your questions don't cover everything that we went over, I'll do a couple of other repeat examples so that you get to see a recap of what we did the day before, the class before, and then I'll move into the newer material, right? I should be able to finish 5.5 today. We'll take a little break, and then we'll do 5.6, okay? So if you haven't taken that Tylenol yet, it's a good time to do it. This is number 14, so this is 5.5 number 14. And I've got the integral of x over x squared plus 1 quantity squared dx. And so I'm not saying what level this is, but clearly there's a downstairs, right? But right before that, before we're looking for a clear downstairs, we're looking for an obvious inside, right? So do you see an obvious downstairs? Yes. So let me just pretend that I think that's the way to go, right? So I got x squared plus 1 quantity all squared, right? And then I have to find the derivative of that, right? In terms of my differentials, so du to dx, right? So du is 2 times, right, power rule, x squared plus 1 to the first power times another 2x, right, the derivative of the inside, dx. And I'm looking, do I have that? Do I have that whole string for du? No. And could I make it happen? Well, could I multiply this by 4? Right? There's the 2 and the 2. Yes. But can I multiply it by x squared plus 1? That's where the problem comes in, because I can't take variables outside of the integral. Right? So I'm going to have this leftover x squared plus 1 downstairs, which is going to cause me trouble. So do you see what I'm saying? I'm saying now I have 1/4 times x squared plus 1. I have to cancel it with an x squared plus 1 times 4x dx times an x squared plus 1 quantity squared. So remember I multiplied by the 4 divided by the 4, multiplied by the x squared plus 1, right? Because that's what I need for my du. But I'm going to have a leftover piece here that's especially trouble if it's downstairs. So this is not the way to go. And by the way, notice it's getting worse. The problem's getting ugly. I mean, it's already ugly. It's a math problem, right? You think you have problems. So it's a big hint that if I introduce a new variable and it stays left over, it's the wrong way to go. Okay? So you're going to see our very next level that we're doing today is I'm going to make a u sub and I'll have a leftover x, right? But that's different than me creating the leftover x. So this turned out to be the wrong way to go completely. And that's okay. There's nothing wrong with trying something and it not working. The thing is, you have to have practiced enough that you're not going to panic when that happens, right? It's like when you're driving somewhere and all of a sudden the road's closed. I live in D.C. It's like these roads go nowhere in D.C. All of a sudden there's a building in the way or something. So that didn't work. So then I'm thinking it could be a new method or it could be a previous method, right? And so, but this one clearly has an inside, right? So I'm going to let u be the inside here. So x squared plus 1. And that's nice because when I do du, I almost see it instantly, 2x dx, right? So now I know I need a 2, and I got to cancel it with a 1/2. How are we doing here? Nice. Charlene, tonight, Adam, nice. David, Chuck, thank you. Charlie, Michael, you okay? You doing okay with these, Michael?
It's done. Yeah, I'm okay.
Nice. Sarana, Neiman, nice. Nima, sorry. Eleanor, nice. Ash, great. It's like I need a bus to pick up all these hitchhikers with the thumbs up. So now I have 1/2 of the integral of 1 over u squared du. Is everybody okay with that substitution? Nice, Serena. Angel tonight, nice. Adam, great. Thank you for the participation. I appreciate it. It really makes it feels a lot less lonely when the class participates. Teaching like this, I hate it, but it'll be over soon. I don't know if math is as bad as some other classes remotely. Does anybody agree with that, or no? Charlie still thinks this is bad.
Chem is a lot worse.
Chem is.
Yeah, doing the labs suck.
Yeah. I know that. You're one of my sources for that lab comment earlier. So this particular problem is now a power rule, right? So I've got an integration of a u to a power. So I've got 1/2 of u to the minus 2. I'm going to add 1 and divide by that new power, and then add a c. How are we doing there? I feel like I'm going fast there, but it's a Calc 1 integral. But some of you didn't do these in Calc 1, so you got to make sure, right? Right? Some of you did not do some of these in. Oh, Angel just sent a little text here. I don't know when you sent it, Angel, but all labs are going back. Angel, you got an email from the school today?
No, I got it a couple weeks ago.
Okay.
Yeah, same. That's why I said organic chem was going back for me.
Oh, right.
I think a lot of us did really bad, like over the past few semesters with chem.
Well, I can say my summer classes, I failed close to 50% of every class. Yeah. Yeah. But several of them cheated. Some of them, just didn't do anything. So, but if you're doing what I'm telling you to do, and you ask for help, you won't fail. If you fail the midterm and then keep doing things as you've been doing, it's not going to work, right? You have to do something different if it's not working. And it's hard for us humans to do that. It's hard for humans to ask for help. But that's what I'm telling you I want you to do. I got to tell you, I had to ask for help. I did this Calc 2 where my study group started to really pay off. Because I had questions on every topic. I'm like, I don't get it. What do you do? So you got to ask for help. If you can ask a peer, it's easy. I'm trying to make it easy for you to ask me, right? I would like you to ask me, but I understand. So, All right, so let me finish this. This is 1/2 of u to the minus 1 over a negative 1 plus c. And so I will pull that negative out, right? And then I've got a 1 over u plus c. And then what is u? Again, I get x squared plus 1, right? So c minus 1 over 2 times x squared plus 1. And you got some freedom there, how you put that into WebAssign. I like to keep things factored, but you don't have to. That was a real big part of Calc 1 when you had to find critical values. There are times now in Calc 2 where we're going to say, oh, who cares if you factor? So, which is nice because I hounded all my Calc 1 students about getting things written in that factored form. But we start to ease up on that a little bit in Calc 2.
I have a question about this one.
Yes, Ellen.
When it was just 1 over u squared, I was thinking we would be doing ln of x as the answer, but should you never really go to that when there's a power in the...
Exactly. Yes, exactly. So our key here is if y equals ln of x, y prime is 1 over x, right? But if y is 1 over x, y prime is 1 over x squared. So So I've got to be
Mm-hmm.
right. So like in your Calc 1 book, which is our same book, chapter 3, at the end, there's a list of all of the derivatives. And I'm saying that should be on your formula sheet, right?
Okay.
Yeah. Yeah, and you can, and so listen, yes, you could make the mistake of thinking that this one is an LN, right? And so I don't know what you might think, but the key is when you're done with your test, okay, you go back and you take the derivative of your answer and see if you get back to where you were.
Right. Yeah.
Right. So that's really the key, is that all of these integrals that you do, you can double check by taking derivatives. And you know, I used to have, like, I would on my test, and you're going to be writing your test on paper as well, but on my test I would put in the little right corner, okay, check. A check meant I think I got it, and a double check meant I possibly verified. And so at the end I would just flip through my pages looking at that right corner and see what I had to look at again, instead of trying to remember everything. You know, oh, I know I didn't do 11 right. Instead of me remembering that and taking up brain space, I would just put these little marks in the corner so I could, you know, I could free myself from any other thoughts.
Mm-hmm.
All right, let's do another example from last time. And so this one, this is number 33. I've got the integral of sine 2x over 1 plus cos squared x, all with respect to x. So this one's kind of strange. Definitely some insides here. There's a 2x inside. There's a cosine inside, right, of the square. But if I try those, I strike out pretty quickly. Okay? So, oh, wait a minute. Is it cos squared of 2x? Sorry. No, cos squared of x. So this one, according to my checklist, is definitely a hole downstairs. Right? So I get u equals 1 plus cos squared x. And it might not be right, and that's fine. Right? And like I said, we're going to go through like these 10 levels. And then we're going to get a new problem today from 5-6 that won't work with any of those. And so in Calc 2, we're continuing this checklist, probably about 10 more types of problems, types of integrals to do. And you're already going, well, how am I going to fit that on my one page? that's So by the way, when I get a formula sheet, I will write out 8 pages, and then I'll cam scanner them to get a PDF of 8 pages, and then I can print it with 4 pages per side, right? And so I don't have to write that small in that case, and so you know, that's what I would do. Even if I had to go to like a Staples or something to get it printed, I think you could even do it at a CVS or something like that. You know, or yeah. I guess you might even be able to go on campus, because the computer labs are open on campus. So that might be a possibility too. But hopefully a neighbor has a printer, or a family member has a printer or something, right? But start building this formula sheet as we go, right? So that you're not doing it last minute, and then you can, as we go, you can decide, oh, I don't need the trig identities. Oh, I don't need the derivatives of the inverse trigs. I got those, right? And you can start to pull things off of there. So what's our derivative here? Does anybody have it yet? Go ahead, Charlie. I can't hear you.
Minus 2x, minus 2 cosec sine x.
Yes, beautiful. So the cosine squared is a power rule, right? So the power comes down times the cosine now to the first power, and the derivative of cosine is negative sine. And then you should recognize this identity, oh, dx, sorry, thank you. And you should recognize this identity as negative sine 2x dx. And that's why I'm saying those trig identities should be on your formula sheets. They will pop up every now and then. How's everybody doing here? Everybody okay with du? Nice. Charlene and Serrano are okay. Everyone else? Anybody? Chuck? Yes. Michael, nice. Eruz, nice. Nima, thank you. So now we're ready to make our sub, right? So I've got the integral of 1 over u du. Okay, there's the ln, right? I see the ln now. So this is the ln of the absolute value of u plus c. And that u value is 1 plus cos squared. That's always positive, right? Is it? Yeah, I mean, kind of. Yes.
Are you missing a negative 1?
Oh, yeah. Yes, thank you. Thank you. Very good. Yes, so negative ln of the absolute value of u. So here's cosine, right? Here's cosine squared. I'll do it in red. Cosine squared is here, right? Cosine squared plus 1 is here, right? So always positive. So I got c minus the ln of 1 plus cos squared of x. I could do something else, but right, I could say it's the ln of 1 over 1 plus cos squared x plus c. That doesn't save me pen strokes. So this one is the one that saves me pen strokes, right? You understand what I'm saying? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. What? Oh, no. No, this one's 2 more. I don't know how I counted wrong. But anyway, you can go crazy trying to simplify things and not get any better. And it's really about the number of strokes of the pen that you're trying to minimize that. You're trying to say as much as you can in the least amount of writing. And this is a coder's anthem, right? We're always trying to code with the least number of keystrokes, least amount of memory. And we want it to be beautiful, in quotes, right? Okay, so I think we're good. We're ready to move on to, we got 4 more levels to do here. Am I right? I finished at 6. U sub downstairs was 6. And again, the numbers don't matter, because when you're good, you don't have to follow the list, right? So 7 I call change of variable. So this is level 7. And what's going to happen is I might have something like x square roots of 1 minus x dx. And then I'm going to get xu du. And so the key is when I do my initial u sub, so the initial u sub leaves a leftover variable of x or whatever. I typically always use x. Some could be theta, etc. But and so then you want to solve your u sub for that variable and then change it. Okay. So everything we've been doing in terms of these u sub is a change of variable, right? We change from the variable x to the variable u. But every time we've been doing it, it leaves nothing left over. It leaves no x's left over. So this particular level, I'm just saying it's going to leave a leftover x or some, right, some nx squared or whatever. And so then you have to manipulate things to get rid of that, right? And so this one is tough. This one's a little bit tough, but we'll do. And there's a couple of nice ones on that review sheet that I posted, right? So I put that in the chat yesterday. If you didn't get it in the chat, I reposted it on Blackboard and it's working now. So you can grab that again and try those, right? I think most of the problems on that sheet are these level 7, 8, 9, and 10 problems because the book is kind of weak on these particular topics, all right? But they show up in Calc 2 all the time. So that's why I'm not torturing you because when you become a mathematician, you got a couple of choices for jobs. Usually military is a big one, where you're working on weapons, code breaking, war type things. Or, and then there's just the artistic side of teaching and trying to discover new theorems and things like that. But so if I worked in the war aspect, I could kill people quickly. But if I teach, I can kill them very slowly, right? So that's what I picked. But because these things all show up in Calc 2, I don't know why the book leaves them out for the Calc 1 students. But anyway, I put them back in. So here we go, change of variable. So let's actually do the one I have here, x square roots of 1 minus x dx. So I'm going through my list, right? And I have a clear inside, right? You're going to see the inside sub is happening the most often, okay? The inside sub happens the most often because that's really the essence of the chain rule. Think about it in f of g of x, right? The inside is some complicated function, right? So here u is 1 minus x, and du is negative dx. Is everybody okay there? So I need that negative on the inside, and I have to cancel it on the outside. And you can put a 1 there if you want, if it makes you feel better with a negative 1 there. Whatever you want to do, right? So the double negatives cancel, right? But now I see I have a negative dx, so in green is du, right? The negative dx is du. And square root of 1 minus x is square root of u. So now I do that initial substitution. I have x square root of u du. And there's my leftover x piece. And so only thing I have to work with is here, right? So what I have to work with is there, and all I have to do is solve that for x, right? So what is x? X is 1 minus u, right? Is that agreeable? Now look at when I did my initial u sub. Do you see it got easy? It got simpler, less pen strokes. And that's really the kind of thing that's hinting at me if I'm going the right way or not. So when I did my initial u sub, right, from here to here, right, from line 1 to line 2, it got easier. So I feel like I'm going the right way. If it gets messier, if it gets more complicated, I'm giving myself kind of a hint that maybe this is not the right way to go, right? So now I have the I have the opposite of the integral of 1 minus u square root of u du. And at this point, you don't have to do what I'm going to do. I'm going to pull that negative back in just because I feel like it. So I've got the integral of u minus 1 square root of u du. I just think if I can make things simple before I start going, and I'll get the same answer here, okay? So you don't have to do this piece. You don't have to bring that piece in. I just see that it comes in easily, right? So here I have a I have two integrals. I have u times square root of u du minus square root of u du. Right, so I just distributed. And you say, well, how am I supposed to know to do that? Well, I mean, you have parentheses. You definitely have the option of distributing, right? But in these particular problems, it'll almost happen every time. So I've got a bunch of power rules. This is u to the 3/2 minus u to the 1/2. Make sure everyone's okay there. It's usually the simple stuff that gets complicated for us as we learn higher level math. And so now I'm doing power rules. U to the 3/2 plus 1 over 3/2 plus 1 minus u to the 1/2 plus 1 all over 1/2 plus 1 plus c. And this will be a little bit of a blast from the past for my previous Calc 1 students, where I'm going to ask you to factor this one. So what do I get? I get u to the 2/5 times u to the 5/2 minus 2/3 u to the 3/2 plus c. I'm going to take out a 2 from upstairs, a u to the 3/2 from upstairs, and a 15 from downstairs. So I'm going to take out a 2 u to the 3/2 over 15 and see what I have left, right? So I should have 3 u to the 2/2 minus 5. That one should bother a couple of you. Lucy, okay? My dogs, now, since I've been teaching at home for 8 semesters, this is my dog's 8th Calc 2 class, and she still can't even hold the pen, you know? So I don't know. There's no hope, I think. She keeps falling asleep in class. She's like, let's do some logarithms. How is this factoring part? We okay here? You want to see me do this a different way? Is it bothering anyone? Bothering? Yes. So the easiest way to do this is to get an LCD. So I'm going to multiply here by 3 and 3 to get a 15, and here by 5 and 5 to get a 15. And now it's easy to see the 15 coming out and the 3 left over upstairs, right? So it's easy to see the 15 coming out downstairs and the 3 left over, and the 15 coming out and the 5 left over, right? And so obviously it's easier to go this way. U to the 3/2 times u to the 2/2 is u to the 5/2, right? When I'm multiplying like bases, I add the exponents. So it's a little bit easier to see it when you go back the other way. But anyway, I have 2/15 times 1 minus x to the 3/2 times 3 times a 1 minus x minus 5 o plus c. So now I'm just doing I'm putting my value of u back in. Is this okay? Am I okay here? Anybody need a minute? And then I'm just trying to simplify that as much as I can. You can see I could factor out a negative. Yuck. They get pretty nasty.
Robert, I'm not sure it's -8.
So I agree with you. It's -2, right?
Right.
Thank you. And please, always, if I make a mistake, I don't mind. Please help me. My teachers used to say they made mistakes on purpose just to see if anyone was paying attention, but
Sounds like my wife.
but I just make mistakes. I'll be honest. And when do we make mistakes? It's important that we realize when do we make mistakes? When we're rushing to do the next line, right? When we're anxious to get that next line written, and we space out a little bit at the end of the previous line. Like as an algebra teacher, I would see all the times, I would see 2x minus 3 here when you're distributing, right? Because you're moving on to that next line. So the very last piece that you're going to distribute, you forget to do, right? Because you're rushing. And it's the same thing with car accidents. You're close to home, you start thinking about what you're going to make for dinner, and poof, right? So it's about, and I'm going fast for the lecture because I want to get through some things, but it's about being able to go back to the previous line, and I do believe I give time for that in my tests, for you to be able to go back to the previous line and double check, right? So right around here, I should have been double checking. Okay, do I definitely get a -2 there, or do I get the -8 there? That type of thing. So right. It's 2 steps forward, 1 step back. Right, do your step, go back and double check. Do your next step, go back and double check. 2 steps forward, go back and double check. 2 steps forward, go back and right. It takes a lot longer to get there, but well, I'm going to just do one of those because there's a couple more of them on that sheet, and I think that the essence is easy. The essential piece of the problem of the calculus is easy. It's the algebra that's not easy, and that's if you haven't recognized that already about Calc 1, right? That was definitely a piece of Calc 1. The calculus was all easy, but getting all of everything to be simplified as much as possible was not easy, right? It gets a little bit in Calc 2. I think I put one of these types of problems on a test in the past 4 semesters, so it's not a real typical candidate of something. It's hard to make these problems happen in the applications, so they tend to not show up. All right, last 3, and then we'll take a break. I know it's almost an hour already, but
Professor Kuhar?
Yes, who's that?
Josh
Caleb
asked if you could do another example in the chat.
Oh, okay, thanks. Yes, Josh and I'm reading the chat, Josh, of this type of problem, of this change of variable problem, this level 7. Yes, okay. Let me set one up, okay? Let me set one up, but not do all of the. Let me kind of get to here with it, okay, and then leave the factoring to you. Is the factoring the issue, Josh, or is it the? I would assume it's factoring is the issue, but Josh, is the factoring the issue, or is it the calculus? All of it. Okay, that's okay. I like that answer. So I'll do another one here, but I won't go all the way through with the factoring. Okay. So I mean, they can get kind of nasty for sure. Like the integral of 2x minus 3 times the square root of 5 minus 2x dx. I mean, this one is just really horrible. And I got one even worse than this on that review sheet. Typically, and you know, I get a lot of grief from this, from students, as I put the most difficult problems on the exams. Because what's the point? I mean, I do put one easy problem on. The very first problem, it says name, and then it's just blank. That's the one problem I put on. That's always easy. But then the rest, I tend to put the most difficult problems on and give only 5 problems. And then inside of every problem unfolds another problem. But if you practice my old exams, you'll be fine, okay? If you stay hyper-focused on WebAssign, which gives a 1-level problem, you're going to struggle a little bit on the exams. And you'll see my exams will I'll give you one problem, it'll turn into another type of problem. And a lot of these are even doing that, right? I do a U sub inside and it turns into a power rule. That's the thought, right? That's 2 types of problems. But just because it's difficult doesn't mean you can't do it, okay? You can do it if you practice. All right, so clearly u is going to be 5 minus 2x, and du is negative 2 dx. So I need a negative 2, and I need to cancel it with a negative 1/2, right? I need a negative 2, and I need to cancel it with a negative 1/2. So now I have negative 1/2 times the integral of 2x minus 3 square roots of u du. Make sure we see that the negative 2 dx became the du, right? These green highlighted piece became du. And then, of course, square root of 5 minus 2x is square root of u. And again, I'm seeing that this has gotten a little bit simpler, right? So I think it might be the right way to go. So, but I have to solve this for x. I don't know if you see it, but I can solve it for 2x and make it a little bit easier. So what do I get? 2x is 5 minus u. And so now I can just plug in for 2x there. You don't have to do it this way, by the way. If that doesn't make sense to you, solve for x, plug in to x. How are we doing there? We okay? Josh is making sense here? Nice, thank you. So, the process continues, right? I think that might be the most difficult part of it. Maybe it's this power rule piece. I could bring in the 1/2. I could bring in the negative. I'm just gonna go, okay, this is negative 1/2 times 2 square roots of u du plus 1/2 u square roots of u du. So I'm just distributing everything, right? And then we're back to where we were before. It'll typically have a 1/2, a 3/2, a 5/2, etc. because we're using that square root there. There are other problems like this, but these are typically the ones I stick to. But do the problems on that sheet that I gave, right, that I posted on the documents, on the handouts part of Blackboard. Okay, let's go 7, 8, and 9. 8, 9, and 10, and we'll take a little break. 8 and 9 are very quick. 10 is very long. 10 is the tough one. And 10 is the one that I put on every test. So, right, the most difficult ones. But you're going to practice them. You're going to do every one that I've done in all my previous tests, and then there's no way. By the way, my midterm last semester was the most difficult I've ever given. And I promise I will never make a test that evil again. So if you can do the midterm from last semester, you can do anything that I would possibly give to you. I almost had a mutiny. They were so mad at me. Of course, one class had an average of 59. The other class had an average of 72 or something like that. So it was the 59 class that still hates me and will hate me forever, but I'm okay with that. If you hate me and pass the class, I've done a good job. Right? If you hate me and you're ready for the other classes, right? I've done what I'm supposed to do. I don't care if you hate me. I got an ex-wife. I'm not supposed to be recording all this stuff. It's okay. It's just a joke. Kind of. All right. Level 8, 9, and 10 are all about the inverse trigs. So we kind of overlap a little bit with a level 1 where you recognize the inverse trig. With a level 3 where you have to do one of those tricks, right? So it's just about recognizing here why I put these at the end. Recognizing here that you've got an inverse trig, right? So so 8 is just a simple inverse trig. So we've already done some, but sometimes they you don't see them in the previous piece. You don't recognize they're an inverse trig, so that's why I'm making these last 3 really look for the inverse trigs, right? And so what could I have? I could have 1 over square root of 1 minus x squared dx, and that's an arcsine. Or I could have a 1 over 1 plus x squared dx, and that is an arctan. But it could be some little funky thing in there, right? It could be something like 1 over square root of 4 minus x squared dx. Could be something like that. And so I don't know if you had a teacher that went through all the formulas. I think it was section, it might have been 3.9 or 3.10, where they just went through all these general formulas so that you could, right? But I'm not expecting you to have all of those formulas. It'd be impossible to have all those formulas memorized. So I want to make this one look like this, right? So what looks different? What looks different there?
4.
The 4. So it's factor or multiply everything by 1 over 4, and so whatever you choose to do is fine. So, but I want to factor out a 4 here, and I get 1 minus x squared over 4, right? And that 4 is going to factor out as a 2 from the square root. So I'm going to try and factor, or do whatever. You're algebraic masters at this point, so you can simplify this as much as you can. But I'm trying to get it to look like this purple circle, right? I'm trying to get it to look like 1 over square root of 1 minus something squared. So now I have a u sub of x over 2. So du is 1/2 dx. And look, I have that. Do you see it? I have a 1/2 dx. So now I see that this is an arcsine of u, but u is x over 2. So just some kind of little simple manipulation to get it back to an inverse trig. Right? That's level 8. Very simple.
Sorry, where is the other 1/2?
Okay. Can I put numbers on there, maybe we can do it that way. Where you at, Eleanor?
At step 3, where you highlighted the 1/2.
Yeah, so that 1/2 came from the square root of the 4 downstairs, right? Square root of 4 is 2. So I now have a 1/2 there.
Okay.
Yeah. And that 1/2 I needed for my du, so I brought it back in to make the du, right? That green part, 1/2 dx is the du.
What would happen if instead of a 4, it was something that you couldn't take out of the?
Yeah, I try to make.
If you can't move the 4,
you can always move anything out.
The square
so
root.
You can always do it. So if it was a 7, right? I would
Square root
get
of
rad
7.
7. Yeah, exactly. So you can always move it out, but I try and make it as nice as I can, and that nice is in parentheses, as nice as I can for you on the test. So I like if I give you a square root, I like to give you square numbers in there to factor out, right?
Yes.
Okay, so I kind of am thinking I did 8 and 9 already. I know I numbered this one 8, but I want to say 8 is just an plain old inverse trig that you see, or an inverse trig like a level 3 with inverse trigs like the one we did today, right? For with Naiant. The one problem we did, number 7 today, where you'd see an inverse trig and the derivative of the inverse trig. Just sometimes you'll miss those, right? So let me just pretend I did 8 and 9, just looking for inverse trigs. And well, I did one the other day, I think, where it's like, right, I had x over 1 plus x to the 4th dx, and it's hard to see that that's an inside sub, right? And so I'm confusing myself with what I'm calling level 8 or 9, but it doesn't really matter. Just 8, 9, 10. After level 7, after change of variable, look for inverse trigs, right? And so right, we did this one the other day. So that's like an inverse trig kind of hidden. But I'd gone through everything else on my list and it didn't work. So now I'm on this inverse trig kind of search. Right? And so do I see an inside? I see it downstairs, but the downstairs didn't work. So then do I see an inside that's downstairs? And that's hinting at an inverse trig again. That's okay. Don't, it's the next level is the one I always ask you. But there's lots of these on that worksheet. Okay. And the worksheet is solutions only, but you just have to pretend I gave you a bunch of problems. It's that first thing I write down, that's the problem, and then I start working on it, right? So, but I think I said inverse trigs, and there's like 3 pages of inverse trigs, and there's my 8, 9, and 10. Who cares about it? I'll stop saying the numbers now. Because the tendency for me is in Calc 2, on your midterm and on your final, I will say solve this by using an inverse trig. I don't usually say that because they have other names. I'll say solve it using a trig substitution. Solve this using integration by parts. We're doing that today. Solve this by completing the square. Solve this by divide and conquer. Okay? So that's what we're going to do right now. So this is my level 10. You're going to see so I'm looking at last semester's final exam. I've got the integral of 1 over x squared plus 2x plus 5 dx. Now there's something, this is a Calc 1 problem, but there's something I'm leaving off of this page that we do in Chapter 5, where I put the limits in from like 0 to infinity. And so that brings this problem into Calc 2. But let's just pretend it's an indefinite integral, right? Where we're just doing an antiderivative here. So I've gone through my whole list, and I don't see this anywhere on my list, right? There's definitely a clear downstairs, but my derivative of downstairs is 2x plus 2, right? And I can't make that variable piece happen upstairs, right? So this one is got to be level 10 for me. So I'm going to try and complete the square downstairs. Now, if you don't remember completing the square, I'm sorry for the torture I'm about to put you through. But basically, I want to group my x terms together, and I want to factor out a leading coefficient that is not 1. So right now I have a 1x squared, so I don't have to factor anything out there, right? I've got a 1x squared. I can leave it alone. I find so now I call this value k, and I get half of k, and then I get half of k quantity squared, and I'm going to add it on the inside and subtract it on the outside. So I factor out the leading coefficient that is not 1. I get the value of k. I don't call it b, right? Ax squared plus bx plus c, because if I factored something out, the b value has changed. So I get k value, I get half of the k value, I add it and subtract it. At this point, I should be able to get rid of the parenthesis and see I haven't done anything, right? I still have equality here, right? This is that 2 steps forward, 1 step back. But my first piece will always become x plus half of k quantity squared. How are we doing there? So now I have the integral of 1 over x plus 1 quantity squared plus 4 dx. And it's starting to look like an arctan. You agree? So I see something squared plus something, right? I want it to be something squared plus 1. Okay? I want it to be something squared plus 1. So I gotta do something with that 4. So this part is difficult, and why it's difficult? Because it goes all the way back to pre-cal, maybe back to algebra 2, depending on how much your pre-cal teacher tortured you with complete the square, which if it was me, I tortured them. So is everyone okay here? Anybody? So I got a couple of cameras on, so I'm seeing some far away eyes, but I have like a spidey sense when when students are like, oh my God, what the hell's going on?
You can divide above and below by 4.
Exactly. Divide every term by 4, or factor the 4 out of downstairs. Right? I can divide everything by 4. So now I have 1/4 of 1 over 1 plus x plus 1 all over 2 quantity squared dx. Mm-hmm. And so it's looking more and more like my arctan.
Mm-hmm.
How are we doing? Are we okay? I've only got a couple of thumbs up that we're okay, so. Okay, there's just a couple more. Nice. Juan, Haoshen, Serrano. Charlene, great. Chuck's there, great. David's there, nice. Eleanor's still got that Scream look. I'll call it the Scream look. Remember the movie Scream? Tonight's got the scream look. There's a bunch of these on that sheet too, and you'll see a little side box where I complete the square, and then you can always email me and ask me to find you a nice video on how to complete the square if that's the issue. Okay.
Yeah, I have to say I took pre-calc 2 semesters ago now, and we did not do any.
Yeah, it happens. I know. We're really working to try and get everybody to teach the same material, but you know what, people are pretty stubborn.
Mm-hmm.
I don't want to teach that. So anyway, now I have a U sub. You'll get it, Eleanor. You'll get it. So I've got x plus 1 all over 2, and du is 1/2 dx, and I see I have a 1/2 inside of my 1/4. Right? I've got a factor of 1/2 there. So I'm going to pull that factor of 1/2 out of that. And I don't have to do that. Like if this part bothers you, that I factored that 1/4 into a 1/2 times a 1/2, you could just say, oh, I need a 1/2 inside, so let me multiply by 2 outside. Right? You could do that same process we've been doing. You don't have to do things the way I'm doing them. You don't have to do your arithmetic the way I do my arithmetic, that's for sure. So it looks like now I have 1/2 of 1 over 1 plus u squared du. So that's 1/2 of the arctan of u, which is x plus 1 all over 2 plus c, and there it is. So what we're going to do is we're going to take a break here, and then when we come back, we're going to do a problem from last semester's midterm like this, and then we'll do the new stuff. Okay. So for sure we're done with 5.5. Okay. So we're done with 5.5. So for sure you can do the problems in the book. You can do the problems in that review sheet I gave. You can do the WebAssign homework. I'm not guaranteed I'm going to get 5.6 done, but I'll be close. Okay. But let's take a break. Let's come back at 9:30. Okay. And I'll leave this, even though I'm going to mute and turn off my camera, the page should still be shared in case you want to keep looking at it or write something down. Be right back.